Hi, in this video, we're going to wrap up section 3.4. We have some data. We're going to do an example of a box plot and talk about how we handle outliers and how they can be depicted in a box plot. Okay, so I reproduced data from the notes on the board here. We have TV watching data in hours per week for 20 children, okay? So I have the data organized at 20 data points, and I stacked them in 5 equal length column rows, so that, 4 equal length rows, so that we can think about breaking up that noodle a little bit, more easily. So we could go through the calculation of the location of the median, and I'll do that. N equals 20. The location of the median is in location n plus 1 over 2. So that's 21 over 2, or 10.5. But if you think about it, this is your 10th data point, and that's your 11th data point. So right over here, right? That's the location of Q2, your median. Oops, Q2, your median, right? So breaking the noodle into 2 equal pieces, we have Q2 is equal to 30 plus 31 divided by 2. And similarly, the data set to the left of the median has 10 data points. We're going to break it between the 5th and the 6th. You can work that out if you like. So Q1 is going to break right here, right? So we're going to break it here. We have Q1, and that's going to be 20 plus 25 divided by 2. And that's 22.5. And over here, our Q3 is going to be between the halfway point between 35 and 38. Okay, so let's go ahead and get that. And we have Q3 is equal to 34 plus 38 divided by 2, and that's equal to 36. Well, I don't know. Okay. So we have our quartiles. I'm going to translate that into your 5-number summary because it's kind of hard to read over there. But my 5-number summary, the minimum 5-number summary need to be listed in the order from minimum to maximum, and for full credit anyway, because our eyes get used to seeing them and interpreting them. They should be in order with commas between them. And that is the numerical summary. So it's 5, 22.5, 30.5, 36, and 66. Okay, so that's our 5-number summary. Let's go ahead and draw a box plot. So the box plot, you need a range that goes from 5 to 66 at least. Well, why don't I go ahead and start it at 0 and go to 70. Okay, so let's see. There's 0, 10, 20, 30, 40, 50, oops, 60. And 70, so more or less linear between 0 and 70. So for the 5-number summary, we're going to go ahead and put a dot for each of the numbers. And for the box plot, we're going to dot the 5-number summary. Okay. So about like that, right? And we're going to put the box around the interquartile data here. and a bar at the median, and whiskers from minimum to Q1 and from Q3 to maximum. So we can look here and see the box spot. All right, so the question is here that I want to discuss is I want to talk about this guy right here. 66. This kid's watching 66 hours of television a week. It's kind of a lot. How do I know? Well, the next kid over is watching 43 hours of television a week, and that's already a full-time job. So you kind of have to think about that, right? And how is 66 an outlier? Is he outside the pattern of the data? So in fact, if we were to think about it and just look at this, we could actually see that 66 seems different because we are smart and we have eyes and we're looking at the numbers and we have a feel as to what's going on everywhere else. But if we were programming up a numerical or a statistical calculator, we would need a hard and fast rule to determine some way, criteria to determine if a number is an outlier. So we're gonna go through this fencing method. This is outlined in your stat lab as well, my stat lab. And the fencing method says that any data point that we're going to find a range, and then any data point that is outside of that range is an outlier. So the range that we're going to do, the upper and lower limits are going to be, so the lower limit, lower and upper limits to define identifying potential outliers. So we're going to form a lower limit or a lower fence, I think sometimes we refer to it as. Okay, and for the lower fence, we're going to look at, it's going to be Q1. So we're going to go to Q1 and we're going to subtract 1.5 times the interquartile range. So we're going to subtract this and then we're going to subtract half of this. So it's going to be somewhere around there. And we're going to do the same thing over here. And then any points that are outside of that range is considered, we can consider an outlier. So Q1 minus 1.5 times IQR. That's my lower limit. Let's go ahead and find out. So we're going to need the IQR. We might as well kind of get that up here. So IQR is 36 minus 22.5. I think that's 7.5. No, it's not. Let's go ahead and take the calculator out. And find the interquartile range. It's always good to have a little bit of accuracy. Okay, 13.5. All right, so Q1 is 22.5. And I want to subtract from that 1.5 times 13.5. So we'll do that multiplication first, order of operations. Okay, so 1.5 times 13.5. And that gives me 20.25. So 22.5 minus 20.25 is 2.25. And how you'll display this on the on your box plot here is you're going to go over to 2.25, which is just here, and put a little hard bracket. So since you have no data points that are less than 2.25, then we have no outliers to the left, low outliers. So let's go ahead and find the upper bound, the upper limit, or the upper fence. And that's going to be Q3 plus 1.5 times the IQR. All right. And Q3 is 36 and we're gonna take 1.5 times 13.5, and that's 36 plus 20.25, and let's go ahead and add that up. So I get 56.25. Okay, so look over at the data to determine if I have any data points that are above my, my upper fence, and I do. So let's go ahead and place the upper fence where it goes. So the upper fence is here. At about 56, oops, sorry, that's not 56. So the upper fence is somewhere like here. And what we do, because we have a data point that's, even if we had multiple data points outside the fence, we're gonna leave that, we're gonna make this whisker go down to the next largest value, so that's 43, maybe like that. You can leave your little fence there, and for all the data points that are greater than your fence, just replace them with a star. Okay, so here we have what we call a modified box plot, and the modified box plot is nice because really, without any sort of confusion, it very easily shows you what the box plot is without the outlying point, the outlier, but it also includes the outlier, so you don't actually lose the information. All right, now, that's more or less all we really need to cover for this section. I did want to show you one thing in the notes, which brings together graphical representations of outliers, of box plots and histograms. So scooting over to the notes for a minute. And we see this center distribution here. This is a bell-shaped distribution. And in this nice bell-shaped distribution, we see symmetry both in the histogram and in the box plot. Also, what you'll notice is that your whiskers are all 1.5 the width of the box plot. That's where the 1.5 comes for the outlier rule. So in a bell-shaped distribution, we have whiskers that are 1.5 of the interquartile range. For a left skew distribution, you would expect your left tail to be longer, and there's asymmetry in your box. The median is not in the middle of the box. And for the right skew distribution, you have a asymmetry. The median is over towards the left, and the tail, the right skew comes up in the box plot as a long right tail. All right, well, that's it. I'll see you in the next chapter.